For decades, the sound of a General Electric locomotive thundering down the tracks was a symbol of American industrial might. These powerful machines hauled vast amounts of freight, forming the backbone of railroad operations across the continent. Among them, certain engines rose to legendary status, defining an era with their sheer capability and widespread adoption. Yet, even the most successful designs eventually reach their twilight, sometimes not due to mechanical failure or a lack of demand. The story of GE's dominant locomotive and its unexpected exit from production is a tale of innovation meeting an evolving world. It's a story about how even greatness can be sidelined by progress and necessity. In the closing decades of the 20th century, General Electric established itself as a titan in the locomotive manufacturing world, steadily gaining ground and eventually surpassing its long-standing rival, electromotive diesel. A pivotal factor in this rise to dominance was a series of engines that became ubiquitous on North American railways, the -9 series. Specifically, the C449W and its alternating current counterpart, the AC4400CW, became workhorses that propelled GE to the top. The C449W, introduced in 1993, quickly became a favorite for its reliability and its substantial 4,400 horsepower output. These direct current, or DC, traction locomotives were designed for heavy-haul freight service, capable of pulling immense loads over long distances. Railroads appreciated their robust design and the efficiency they brought to their operations. But it was the AC4400CW, arriving shortly after, that truly solidified GE's leadership. This engine, also rated at 4,400 horsepower, utilized alternating current, or AC, traction motors. AC traction was a game-changer. Unlike older DC motors, AC traction motors offered superior adhesion, meaning they could put more power to the rails without slipping, especially when starting a heavy train or climbing steep grades. They were also simpler in design, more reliable, and required less maintenance over time, despite a higher initial cost. Major Class 1 railroads like Union Pacific, CSX Transportation, and Canadian Pacific embraced the AC4400CW, making it one of the most successful and widely produced locomotives of its time. Thousands of these units were built between 1993 and 2004, forming the backbone of freight fleets across North America and even finding homes in other countries. The -9 series, including the AC4400CW, was not just an engine. It was a symbol of GE's engineering prowess and a testament to its understanding of the railroad's needs for powerful, dependable motive power. It was, by many accounts, GE's greatest locomotive engine to date, defining a generation of rail transport. While the -9 series locomotives were busy hauling the nation's goods, a significant shift was occurring in the regulatory landscape. Environmental concerns were growing, and with them came increasing scrutiny on industrial emissions, including those from diesel locomotives. Diesel engines, while incredibly powerful and efficient for their tasks, were also known contributors to air pollution, specifically emitting particulate matter, PM, and nitrogen oxides, NOx, both of which have environmental and health impacts. In response to these concerns, the U.S. Environmental Protection Agency, or EPA, began to implement a series of progressively stricter emission standards for locomotives. These standards were introduced in tiers, starting with Tier 0, which became effective in 2000 for locomotives manufactured between 1973 and 2001. Tier 1 standards followed for locomotives manufactured from 2002 to 2004. However, the real turning point for the locomotive manufacturers came with the looming deadline for Tier 2 emission standards. The Tier 2 standards were significantly more stringent, requiring a substantial reduction in both NOx and PM emissions compared to previous tiers. These regulations were set to become effective for all newly manufactured locomotives starting in January 2005. This was not merely a minor adjustment. It demanded a fundamental rethinking of diesel engine design. For companies like General Electric, it presented an enormous challenge. Their highly successful FDL 16-cylinder engine, which powered the Dash 9 series, was a proven performer, but it was designed under older regulatory frameworks. Meeting the new Tier 2 limits would require more than just minor tweaks. It would necessitate a significant technological leap. The clock was ticking, and failure to meet the 2005 deadline would mean an inability to sell new locomotives in the lucrative North American market. Faced with the strict Tier 2 emission standards, General Electric found itself at a crossroads. Its legendary FDL engine, a 16-cylinder powerhouse that had served faithfully in the Dash 9 series and earlier models, was not inherently designed for such low emissions. This engine was known for its durability and power, but squeezing out cleaner exhaust while maintaining or even improving performance was a monumental engineering feat. The prospect of simply modifying the existing FDL engine to meet the new standards proved too complex and perhaps too costly without compromising other critical aspects like fuel efficiency or power output. GE Transportation committed heavily to this challenge, investing over $200 million and in some accounts up to $400 million over more than 6 to 8 years into research and development. The goal was to create an entirely new engine platform that could comply with the Tier 2 regulations without sacrificing the performance and reliability that railroads had come to expect from GE. This ambitious project led to the development of the GE Evolution series and at its heart, the groundbreaking GEVO engine. The GEVO engine, specifically the GEVO 12, was a radical departure from its predecessor. Instead of 16 cylinders, the GEVO 12 had 12 cylinders. This might seem like a step backward in terms of raw power, but GE engineers optimized every aspect of the new design. They incorporated advanced features such as electronic fuel injection and sophisticated turbocharging systems. These innovations were crucial for precisely controlling combustion and reducing the formation of pollutants like nitrogen oxides and particulate matter. The GEVO engine was engineered from the ground up to be cleaner burning, more fuel efficient, and just as powerful as the FDL engine it was replacing, all while meeting the stringent Tier 2 limits. It was a testament to GE's commitment to adapting to the changing regulatory environment and maintaining its leadership in the locomotive market. The extensive research and development culminated in 2002 with the unveiling of the first prototype of the GE Evolution series. These new locomotives, powered by the innovative GEVO 12 engine, were designed to be the direct successors to the highly successful Dash 9 series. The first production units of the Evolution series began entering service in 2005, perfectly timed to meet the EPA's Tier 2 emission standards. The flagship models of this new series were the ES44AC and the ES44DC, both rated at 4,400 horsepower, mirroring the power output of their Dash 9 predecessors. The ES44AC with its AC traction became particularly popular, building upon the advantages that the AC4400CW had already proven. These locomotives were not only compliant with the new emissions regulations, achieving up to a 40% reduction in nitrogen oxides, NOx, compared to earlier models, but they also boasted improved fuel efficiency. This combination of environmental responsibility and economic benefit made them highly attractive to railroad operators. The Evolution series quickly became a dominant force on the rails, much like the Dash 9s before them. Railroads across North America, including major players like BNSF Railway, Union Pacific, and CSX Transportation, placed substantial orders for these new engines. The ES44AC in particular has been widely adopted by every Class I railroad in North America, becoming the most successful modern GE locomotive model in terms of units sold. The introduction of the Evolution series demonstrated GE's ability to innovate and adapt, fundamentally changing their core product to meet new environmental requirements while continuing to deliver powerful and reliable locomotives. This new line wasn't just a replacement. It was a significant step forward in locomotive technology, setting new industry benchmarks for efficiency and lower emissions. The introduction of the Evolution series, particularly the ES44AC, marked the official end of an era for the Dash 9 series. With the Tier 2 emission standards for new locomotives taking full effect in January 2005, GE simply could no longer produce the AC4400CW or C440C9W for the domestic market. It wasn't a matter of the Dash 9s failing or becoming obsolete in terms of their core capabilities. They were still powerful and reliable machines. Rather, their production ceased because their engine technology, the venerable 16-cylinder FDL, could not economically or practically meet the new, much stricter environmental mandates without a complete redesign. The transition was swift and decisive. The ES44AC directly replaced the AC4400CW in GE's product catalog, becoming the new standard for high-horsepower freight locomotives. Similarly, the ES44DC took the place of the CEVO9W. This meant that what many considered to be GE's greatest locomotive engine was, in a sense, killed by regulatory pressures rather than competitive shortcomings. The economic and environmental landscape had shifted, and GE, as a leading manufacturer, had to shift with it. For the railroads, this transition meant investing in new technology to ensure their fleets remained compliant and efficient. While many Dash 9s continued to operate, the production lines at GE's Erie plant began churning out the newer Evolution Series models, cementing their place as the new face of American railroading. The decision to discontinue the Dash 9 series was a strategic necessity, a calculated move by General Electric to stay ahead of environmental regulations and maintain its market dominance through technological advancement. It highlighted a critical reality of modern industry. Even successful products must sometimes make way for progress driven by evolving societal and environmental standards. Despite being officially phased out of production for new units in 2005, the legacy of the GE-9 series, including the AC4400CW and CE9W, is far from over. These locomotives were built in such vast numbers and with such robust construction that thousands of them continue to operate on Class 1 railroads across North America even today. Their continued presence on the rails is a powerful testament to their initial design, reliability, and the sheer power they offered. Many of these veteran engines, now nearly 2 decades old or more, are still performing vital roles in heavy freight service. Some railroads have even undertaken extensive rebuilding programs, modernizing older Dash 9 units to extend their operational lives, and sometimes even upgrading them with AC traction motors and contemporary control systems. This willingness to invest further in these older models speaks volumes about their fundamental soundness and the value they still represent to their owners. The Dash 9 series represents a pivotal chapter in General Electric's history and in the broader story of North American railroading. They were the engines that helped solidify GE's position as the dominant locomotive manufacturer, proving their mettle day in and day out across countless miles of track. Their retirement from new production was not a failure, but a strategic evolution, a step necessary to meet stricter environmental mandates and introduce an even more advanced generation of locomotives. As trains powered by the Evolution series continue to define the current era, the Dash 9s serve as a reminder of the engineering triumphs of the late 20th century and the constant march of progress that shapes our world. They are the legends that paved the way for the future, still contributing to the nation's economy, one heavy freight train at a time. General Electric's decision to discontinue their highly successful Dash 9 series locomotives, particularly the AC4400CW, was a clear response to the evolving environmental landscape. It was not a judgment on the engine's capability or popularity, but rather a strategic adaptation to the U.S. EPA's stringent Tier 2 emission standards that took effect in 2005. This move led to the birth of the innovative Evolution series, powered by the cleaner GEVO engine, ensuring GE's continued leadership in the industry. The story of the Dash 9 is a powerful example of how environmental regulations can drive technological advancement, forever changing the face of transportation. If you found this journey into locomotive history and technological change fascinating, remember to like this video, subscribe to our channel for more compelling stories, and share your thoughts in the comments below. We love hearing from fellow history enthusiasts.